when you select a face in Solid Edge in the synchronous environment, you're going to be prompted with this arrow. And that arrow, by clicking on it, will perform a move. It'll offset that face from its original position. In this case, I've got a sheet metal model open, so by clicking on one face, it will maintain sheet metal properties like the thickness of the material and that bend radius. And if I bring it in here, it'll even put in bend relief relative to the other faces. So I'm going to key in a value, let's say a 1/4 inch from where that was originally. And that's gone and offset that. Now, if I click the space bar, what I can do is I can select other features or faces. In this case, I might grab this countersunk hole. Now when I execute that move by clicking on that arrow, you're going to see that it brings the hole along with it. What I'm telling the system here is I'm saying, I want to move this face, but when I do, I want to bring this other face or feature along with it. Or in other words, maintain their relative distance while I execute this move. So let's go and offset that by another 1/4 inch. Now the other thing we can do is that we can move our steering wheel really anywhere to establish a control point. And an example of that would be, let's say I want to move this tab in, maintaining the same relevant distance to this hole, or relative distance to this hole. But what I want to do is I want to put my steering wheel on that edge right there. Because what that's going to allow me to do is line up the end of this bend with the edge of this part. So I'll go and start that move, and then just pick up on a key point like where this bend meets the face, and I've lined those two up. So not only can we select multiple faces, we can also select what our control point is from. So this ability to select faces gives us a lot of control. If I wanted to move this whole tab back and forth, for example, I'd pick up on this face, hit my space bar, and grab this face. So by then clicking on the move and maintaining the same relative distances, I can slide this tab around anywhere I need to go. And you see I can even kind of come off the part here. It'll maintain sheet metal conditions like corner relief and whatnot. Maybe I want to move this whole tab as well as the hole. Another way of doing this instead of clicking on everything is to just put a box and kind of pick up on all the faces that are relevant. Now, in this case, it's got some additional faces, but when I pick a move to this side, Solid Edge will kind of filter out those faces because they're not normal to my direction of motion. Only faces that are normal to the direction of motion will actually be moved. So I can keep that same select set and this time move out this way, and you see that everything stays maintained here. Relationships, or rather dimensions, are just another form of that. A dimension is basically a handle point that lets you drive the position of a part by its distance from another face. When I place this dimension, it takes me into the edit mode, and you can see that it's got this face over here highlighted. It's light blue. And that means that if I adjust that dimension, that face will move. I've got directional control in a synchronous dimension, meaning that if I click the other way, you see that my icon here changes and the far face highlights. And now I can make my dimensional change by moving the opposite face. Similarly, we have a so we can move in both directions here, and I can key in my value. And in this case, it's moving both faces to accommodate that change. What you can also do is you can drive with a dimension, but before selecting that dimension, you can pick up on some faces. So for example, maybe I want to grab this hole and then make this adjustment, and it will always remember when I click on the dimension what my last directional decision was. And in this case, the last thing I did was moved it in both directions. In this case, I'm just going to move this one face, but notice that because I had highlighted the hole first, that hole remains highlighted. So when I go to make that move, that hole is going to follow along with the move. Similarly, if I switch directions here, you'll see that that hole will follow that face along. Interestingly, if I go and adjust it in both directions symmetrically, the hole is going to follow in this case, left-hand side. And really what it's doing is, the way it behaves is the features that you select to go along with a dimensional move will always follow whatever face they're close with in a symmetric dimensional change. So just to illustrate that in a little less wordy way, if I were to just grab this hole here and move it a little closer to this side of things, and then with it selected, click on my dimension and do a dimensional change, you see now it's following the right-hand side. Whereas if I were to move this over to a little bit closer to the other side and did that same move, now it'll follow the left-hand side. So that's sort of how it behaves. So just to give you an example of that, let's escape out of this, and maybe what I want to do is first I want to position my hole so that it's centered on this tab. So I'm going to change my key point filter to center. I'm going to move this over and find the center point of that edge on the tab. Now with that correctly positioned, maybe I want to then adjust this so it lines up with an edge on my this cutout here. So I'm going to put a box around all of these guys, and then using the hole as my control point. And by default your steering wheel will want to sit on the face of a hole, so I can just immediately start to adjust and click up on, and I'll change my key point to end point here, just pick up on the face of that there. Now keeping those selected, I can then go and adjust this. In this case I'll do it maybe just on this side, and because I had those faces selected, it maintains that distance. So you can see that depending on what we select and the direction of the dimensional change, we sort of got unlimited flexibility in terms of how we modify our model. Let's look at one more factor, and I'm going to click on this face and turn on my live rules, which up until this point have been suspended. So I'm going to click that to turn them on with that face selected. And now notice that when I move to adjust this face, the face on the opposite side also adjusts. And that's because if we look down at live rules, we'll see that Solid Edge has detected symmetry about the ZX plane. And even though I'm in the middle of the move, I can reach up here and turn on my base coordinate system, and you'll see that it kind of lies right in the middle of these two faces, meaning that Solid Edge detects symmetry. So what that means is that, again, using the same principle as before, picking up on deciding what I want to select, and thereby deciding what relative distances I want to maintain, with live rules on, it will do that and maintain geometric conditions, in this case like symmetry. So you see that I can move that out or back. Maybe I'll make that 1 inches. And dimensions in this context function the same way. If we drop a dimension between these two faces here, you'll notice that with symmetry turned on, it doesn't matter which direction I choose, because symmetry is going to enforce that change on both sides as long as I have that turned on. I can also grab another face and then click the dimension and move that so that the relative distance is maintained. So it gives you an idea of the type of flexibility we have here. So let's take a look at this. Let's say we wanted to make this whole bracket, change this whole bracket such that this distance here is, let's say, 8 inches. But we want to maintain the same flange width exactly as it is right now. And we also want to maintain the distance between this tab and the far edge here, and this hole in the far edge right here. And then in doing so, we also want to leave the cutout exactly where it is. So think about that for a second. So the first thing we want to do is grab all the additional faces that we want to include in this dimensional move. So I'm just going to put a box around this, say you guys are coming with me. Then I'm going to adjust the dimension, and I want to move this face because that's where I want my tab to follow along. And symmetry should take care of the rest. Now as I do this, the only thing I forgot to do is grab that outside edge. So I'm just going to hit a Control-Z to bring it back. It'll remember my selection, and I'm going to pick out on that outside edge. You can also just put a box around all that material too. That'll accomplish the same thing, and adjust that, and that'll be, let's type in 8. And I always like to, when I click my dimension, just to make sure that it's going to do what I want to do, I like to roll my mouse wheel to kind of start the movement, and then I can observe to see that it's doing what I want it to do. And if it's not, I can hit Control-Z or undo to get out of that command and adjust my selection. So that's always a good practice, just to make sure that you're getting the behavior you want. In this case, we're changing the width. The tab and the hole are coming along with it, but the cutout over here is staying exactly where we put it. So that works out really well. I'll show you a couple of other tricks while we're in here. If I wanted to ensure that this cutout was centered, because we're not entirely sure right now, the easiest way to do that is just to put a box around that cutout, grab all those faces, and then what I'll do is I will position my steering wheel on the midpoint of this hole. Just while I'm doing this, another way of grabbing features, of course, is to actually grab the cutout in the feature tree. I don't have a cutout here, so I will have to put a box around that. But what I essentially want to do here is position my steering wheel on the midpoint. So I set my feature to midpoint, and you'll see it'll want to kind of jump to that midpoint that you click. And then when I start my move command, I can then line it up with the center of my origin here. And again, to do that, I'll have to switch my key points to endpoint to be able to pick up on that center point. So now that I know that my cutout is centered, and if we wanted to test that, I could click on a face, make sure that Live Rules is on, and then just adjust it, and you'll see that the symmetry lights up in Live Rules saying that it's been detected, and it behaves accordingly. Here's another thing to notice. If I grab, let's say, this face as well as the outside edge, and then I grab this face as well, with Live Rules turned on, if I attempt to make that move, what you're going to see that I get an error. Solid Edge is telling me you can't actually do that. And the reason is because it's trying to, I'm basically commanding it to do two opposite things. On one hand, I've selected this face and I want it to move along with the rest of them. On the other hand, I have symmetry turned on, so it can't enforce symmetry and do what I want it to do at the same time. If we were to turn off symmetry, you'd see that what it's actually trying to do with that far face is bring it along. And notice as it does so, all the other faces and all the other features that I didn't select maintain where they are. So the message in all of this is that movements in Solid Edge depend on what is selected and the direction you drive your dimension. And remember, if you want to use a dimension to drive more than just the faces to which it's attached, and in this case you can see this dimension's attached to that face, and if we flip directions, that face there. If you want to move more than just those two faces, you have to select the other features ahead of time, and then grab that dimension. And then you'll be moving all those features combined. And of course, keep an eye on Live Rules because they will enforce symmetry and in a lot of ways save you a lot of time. But if ever it's not doing what you want it to do, you can always just turn off either the individual Live Rule or Live Rules globally by clicking this.